Hello viewers, in today's class we are going to discuss yet another important and conceptual problem from limits involving greatest integer function, right? So here we have to discuss this problem which is discuss the limit x tends to 0 and we have greatest integer of x square divided by x square, right? So here we have the square of greatest integer of x, right? And we have to see whether the limit of this function when x approaches to 0 it exists or not, right? So for this what we will do, we'll find out the right hand limit and the left hand limit, right? And we'll see whether the right hand limit exists or not, and similarly the left hand limit exists or not, right? So first of all, let us find out the right hand limit. So now the right hand limit, it is written as RHL, and we have limit x tends to 0 plus. So the positive sign shows that we are approaching towards x is equal to 0 from the right of x is equal to 0, right? See, here we have the number line and here we have x is equal to 0, right? So when we find out the right hand limit, we are approaching from the right of x is equal to 0, right? So now here limit x tends to 0 plus, and we have the function the square of greatest integer of x divided by x square, right? So now here we'll take x is equal to 0 plus h, right? And here we are taking x is equal to 0 plus h because we are approaching from the right of x is equal to 0, and we are somewhere here very close to x is equal to 0, right? So this point is 0 plus h, right? And similarly, when we'll find the left hand limit, we are very close to x is equal to 0, and this point is 0 minus h, right? Okay, so here we are in the neighborhood of x is equal to 0. So when we take x is equal to 0 plus h or h, and when x tends to 0, obviously h tends to 0, right? And here this quantity h is a very small quantity, right? But this quantity is it lies between 0 and 1, and h is a positive quantity, right? So now let us rewrite this limit in terms of h, right? So the right hand limit is now limit h tends to 0, and here we have x greatest integer of x, and here we have the square. So we can now take x is equal to h. So here we have h, here we have square, and here we have h square, right? Okay, so now here we'll use the definition of greatest integer function, and we'll see that the value of greatest integer of h should be equal to 0. Why? Because h, it lies between 0 and 1, right? See, here we have 0 and here we have 1. So h lies between 0 and 1. So the greatest integer of h should be equal to 0 by virtue of the definition of greatest integer function, right? So we have a limit and we have h tends to 0, and see this quantity is now 0, right? So we have 0 and here we have h square, right? So this is 0 square. So now this limit becomes 0, right? So the right hand limit of this function when x approaches to 0 is 0, right? Now let us find out the left hand limit. Now the left hand limit is limit, and here we have x tends to 0 minus, and we have the function the square of greatest integer of x, and here we have x square, right? So now we'll take here uh, x is equal to 0 minus h, right? So here we'll take x is equal to 0 minus h, and which is simply equal to minus h, right? And the remaining conditions are same, that is h is a positive quantity and h it lies between 0 and 1, right? Okay, so now here x tends to 0, so h also tends to 0. So we have the left hand limit, that is limit h tends to 0. Now we are writing this limit in terms of h, right? So here we have minus h, and here we have the square, and here we have minus h square, right? Now here we have to pay special attention, right? See, we have limit and we have h tends to 0, and here we have the square of greatest integer of minus h, right? And here minus h square is positive h square, right? Okay, now see, here h lies between 0 and 1, right? And now if we multiply this inequality throughout by negative sign, we'll have the inequality 0 greater than minus h greater than minus 1, right? Because once we multiply throughout by negative sign, the direction of the inequalities get reversed, right? So we can now rewrite this inequality as minus 1, and here we have minus h, and here we have 0, right? So this is an important inequality, and this suggests that minus h it lies between minus 1 and 0, right? So here we have minus 1 and here we have 0, right? So minus h it lies somewhere between minus 1 and 0, and by the definition of greatest integer function, the value of greatest integer of minus h is minus 1, right? So this is an important result, right? So the greatest integer of minus h is minus 1. So if we take this value here, we'll get a limit h tends to 0, and here we have minus 1 square, and in the denominator we have h square, right? So this is the limit h tends to 0, minus 1 square is simply 1, so we have 1 over h square, right? So now we see that when h tends to 0, then obviously 1 over h tends to infinity, and similarly 1 over h square also tends to infinity, right? So this limit is not defined, right? So here we see that the limit of the right hand limit of this function when x approaches to 0, it exists and it is equal to 0, but the left hand limit, it does not exist, right? So this is not defined. So we can claim that the limit of this function when x approaches to 0, it does not exist, right? So this is how we can solve these type of problems related to limits, right?